So thank you and welcome to this information session, which is being presented by SafeWork SA and Weld Australia, answering the question, welding fumes, what's the deal? My name is Katie Gesner. I'm an Education and Engagement Advisor at SafeWork SA, and I'll be hosting this webinar. In this session, we will attempt to answer some of the most common questions about controlling exposure to welding fumes. Before we get started, I would just like to take the time to respectfully acknowledge the Kaurna people as the traditional custodians of the lands which we meet today, and the Aboriginal and Torres Strait Islander people listening to this session. We pay our respects to elders past, present and emerging, and recognise and celebrate the diversity of Aboriginal and Torres Strait Islander peoples and their ongoing cultures and connections to the lands and waters of South Australia and Australia as a whole. Before I introduce you to our presenters today, I just want to give some background about why we're talking about welding fumes. So a little over a year ago, SafeWork Australia rolled out a revision to the workplace exposure standard for welding fumes, reducing it significantly. And since then, we've received a lot of inquiries and concerns from businesses and workers trying to adapt to these new standards. So in today's session, we hope to provide some further guidance and information in this area so PCBUs can successfully achieve compliance. So now let me introduce our presenters today. So first of all, we have Richard Kerry-Clark, who is the Principal Occupational Hygienist in the Work Environment team at SafeWork SA. So Richard graduated in biochemistry in 1986 from the University of London and has a postgraduate diploma in regulatory toxicology from the Royal Society of Apothecaries, which has nothing to do with leeches. He worked initially for the Medical Research Council, doing cancer research, then general toxicology, before spending almost 25 years with the UK Health and Safety Executive. During that time, Richard worked in all areas of occupational toxicology, immersed in interpreting in vitro studies, animal studies, and human epidemiology. He represented the HSC and the UK in various European Union technical working group meetings before Brexit, as well as working on OECD committees and the World Health Organization program on producing concise international chemical assessment documents. Richard then spent about 10 years doing major hazards work across the 1,000 or so major hazard facilities in the UK. In 2017, he started work with SafeWork SA, firstly in the investigations team, then with chemical licensing, then major hazards, and finally ending up in perhaps his true home as Principal Occupational Hygienist in the newly created Work Environment team, where no 2 days are the same. Richard has been exposed to chemicals for most of his lifetime, and it shows. Welcome, Richard. Thank you for being here.
Thank you.
We also have Bruce Cannon, who is the Technical Publications Manager and Principal Welding Engineer at Weld Australia. So Bruce graduated with a Bachelor of Applied Science, Metallurgy, from what is now the Federation University in 1977, commencing at AINS's Port Kembla Steelworks in 1977. He held positions in mechanical testing, metallurgy, and marketing before joining the welding group in 1985. In 1993, Bruce was seconded to the Welding Technology Institute of Australia as its welding engineer, providing technical support to the welding industry, revision of the WTIA's technical notes, facilitation of seminars, training programs and conferences, and representing the WTIA on national standards committees. Bruce rejoined BHP Steel in July 1995 and continued to provide welding engineering support to their mills and customers in Australia and internationally, and presented lectures to postgraduate welding engineering students at the University of Wollongong. In April 2001, Standards Australia invited him to chair its Committee on Structural Steel Welding and joined the WTIA's Education Board in October. In May 2003, Bruce was awarded his diploma as an international welding engineer. So Bruce retired from BlueScope, formerly BHP Steel, in November 2015, before taking up his current position with Weld Australia, working in roles including representing the interests of the Australian welding industry on national and ISO standard committees, revising its technical notes and authoring new technical documents to support the industry. In 2022, he was awarded the Thomas Medal by the International Institute of Welding for his work on international standards. Currently, his work is focused primarily on welding and related safety, including both electrical safety and welding safety. So welcome, Bruce. Thank you very much for being here.
Thank you so much, Katie.
Okay, so here's just a quick overview of what we'll cover. So first of all, we'll provide some background information about why these new exposure standards came into effect. We'll discuss the science behind welding fumes and why exposure to them is so dangerous. And then we'll discuss the new exposure standards at length and provide practical advice on how PCBUs can successfully manage the risk of exposure to welding fumes and stay under that limit. And then finally, at the end, we'll have a Q&A session where Bruce and Richard will endeavour to answer some of your questions. So please stick around to ask those at the end. To ask a question, and you can do this anytime throughout this presentation, you can click on the Q&A tab at the top of your screen and write your query in there. And we will look at those at the end. So we won't be answering any questions during the presentation. One other important thing is that this session will be recorded and it will be uploaded to our YouTube channel in the next day or so. So if you want to watch this later on, it will be available there. The slides themselves, though, will not be available. Also, if you have any, if there's any tech issues or anything like that, you can pop them in the chat. I will be monitoring that throughout the session. Okay, so Richard, I'm going to start with you. Can you tell us a bit about the background behind these new exposure limits and why these came into effect?
Okay, thanks, Katie. Okay, well, for this audience, I probably don't need to explain too much, but just to be really clear that we're focusing on the high temperature process of joining two or more pieces of metal together. The welding of plastics is not dissimilar, but essentially involves a whole range of different chemicals, and that's going to be outside of the scope of today's presentation. We're focusing on metals. So the welding process is typically high temperature, and that generates airborne metal vapors or fumes of metal particles. But just be aware that other chemicals in vapor form could be evolved. So, for example, due to paint or oils or other dust contamination that might be on the metal surface. Also, to be aware that welding has a whole range of other hazards, not just chemicals, that I'm going to touch on very lightly as we go through the presentation. Okay, welding fumes were recently classified by the World Health Organization, WHO, their International Agency on Cancer Research, otherwise known as IARC. So the profession was classified as carcinogenic based upon human epidemiology studies. Now, IARC does things a little differently. Sometimes it classifies chemicals, sometimes it classifies occupations. Here, so this pronouncement falls short of identifying the exact causative agent, but clearly there are a number of things that are in the mix, like nickel, manganese, hexavalent chromium. So some of those are proven human carcinogens, some are probable human carcinogens. So I thought I'd try and explore some of the health data that are available to us in South Australia. And within SafeWork SA, our main source is from Return to Work SA, who handle work-related compensation claims. So since about 2015, so not quite 10 years, I could see that there were about 800 claims related to jobs that may have involved welding, and I'm being deliberately cautious with my wording there. Less than a handful appeared to make reference to any sort of respiratory illness. So mainly it was things like blunt force injury, sprains, strains, musculoskeletal injuries, and none with cancer. That's not to say that there isn't a problem, because I'm sure that there is a huge amount of underreporting, and during the interview phases, getting clarity on what it was that workers were actually exposed to or what they were actually doing, to make a definitive link between a history of work and the illness. Well, without clear disease markers, such as mesothelioma exists for asbestos as a clear marker, this can get really uncertain, and it can be quite a brave call by a diagnosing physician to make that sort of link.
Thanks for that, Richard. So moving to you now, Bruce, could you explain a little bit about, I guess, the science behind welding fume generation and why it's harmful to health?
Yes, certainly there, Katie. In 1997, the then WTIA, which is now Weld Australia, in conjunction with the University of Wollongong and the then Cooperative Research Centre for Materials Welding and Joining, published their fume minimisation guidelines, and I'll show this later on. This work was based on fume measurements taken under still air conditions. In other words, it's a worst case scenario, and demonstrated that the particulates are generated at the heat source and are confined to the plume. It is crucial to note, though, that the plume may not be visible to either the welder or, depending on the process, the observer. And aside from the visible fume, the work showed that ozone, which is a lung irritant, is generated by the ultraviolet radiation from the arc well beyond the arc zone, and a level of ozone protection for the welder is required. More recently, Apex Welding Safety, in a recent independent study, showed that ozone levels will be exceeded in under 10 minutes of arc time. So that's not very long. The study also reported that a disposable P2 respirator impregnated with activated charcoal is only suitable for nuisance levels of ozone and is ineffective in the levels of ozone produced during welding. In all cases where personal respiratory protection is used, it must be fitted correctly and maintained to be effective. Disposable P2 masks, for example, are ineffective in protecting bearded welders because a seal between the face and mask cannot be achieved. Powered air purifying respirators, though, are highly effective if maintained and used correctly, and it can filter out in excess of up to 99.5% of particulates. Now, just to put this weld fume particles and facial hair into perspective, just take a look at the slide. And welding fume particles are extremely small, so can penetrate deep into the lungs where gas exchange takes place, and in most cases are not removed. In other words, they are respirable. They can also be in the nanoparticle range, in other words, smaller than 100 nanometers. At this size, these particles can remain airborne for up to 48 hours. Given the size of human hair, bearded welders will find it difficult to get a P2 mask that fits and seals correctly. It is likely that weld fume will leak into the mask around the edges as the welder breathes. Be aware that visible plume, though, is an indication that exposures may not be well controlled in the workplace, particularly if the plume remains suspended in the building where welding is taking place. However, an absence of a visible plume does not indicate a safe level of exposure, depending on the materials and consumables involved. Powered air purifying respirators and air-fed respirator systems provide positive pressure with clean filtered air in the welder's breathing zone, and will therefore present the wearer's exposure to weld fume. Now, looking at this slide, all arc welding processes produce fume, some more so than others. The level of fume produced will vary with the conditions of welding. Looking at some relative fume generation rates, It is important to note that the weld and related fume is not always visible, as I have mentioned, and it is this non-visible component that is potentially the most hazardous because of its particulate size. Occupational hygienists may refer to larger visible particulates as the inhalable fraction, which can be trapped by the nose and the body's mucus defences, and the fine particulates as a respirable fraction, which I mentioned earlier, because they pass directly through the lungs and then potentially into the bloodstream and around the body. This graphic on the left, the blue graphic there, is modified from a similar one published by the Australian Cancer Council, and it reflects fume emission rates determined during preparation of Weld Australia's fume minimisation guidelines, which you can download free of charge from Weld Australia's website. As an aside, you can scan the QR code above the document on your screen, and it will take you directly to the document, which can be downloaded free of charge. Much of this information being presented today, including background material, can be found within this document. Going back to the graphic, you will notice that flux cord arc welding will have quite a range of generation rates, as this group covers gas shielded flux cord consumables, hence the trade names such as dual shield and outer shield, and there are others, and their metal cord variants, and those that are self-shielded, which generate a lot of visible fume. In general, the higher the amperage, the greater the fume generated. Consumable and power source manufacturers are doing a lot of research to minimise fume generation rates for the gas metal arc and flux cord processes. Be aware too that fume generation rates for thermal cutting can be very, very high, and the fume generated just as hazardous as weld fume.
Thanks for that, Bruce. Richard, just over to you now. We've got some information now about the science behind weld fume generation. Can you tell us about the new exposure level?
Sure. Well, briefly, there are two overarching workplace exposure standards, or WESs. One for welding fume in general, and the other for fume generated when welding aluminium. Numerically, they're both the same. They were 5 milligrams per cubic meter as an 8-hour time-weighted average. Now, the general welding fume has been revised to 1 milligram per cubic meter, and there's a proposal that was generated earlier this year from Safe Work Australia, a proposal to reduce the aluminium welding fume WES to the same number, 1 milligram per cubic meter. That's not yet in place, but is quite likely to happen towards the end of the year. However, both of these there's a caveat here. More stringent standards may apply depending on the composition of the fume. So, for example, if you've got hexavalent chromium or nickel or cadmium or manganese, so those lower limits may apply, and I'll just talk about those as well. So here's a table that shows some of those specific substance WESs, the 8-hour time-weighted averages. Now, so the middle column there shows the current workplace exposure standard, but you'll see that from 2026 onwards, there are some fairly dramatic changes. So in some cases, it's a 10-fold reduction. So for nickel, cadmium, manganese, and for, excuse me, hexavalent chromium, there's no limit that's actually being set, but the requirement is to either eliminate or reduce so far as is reasonably practicable. Also note that from 2026, which is not all that far away, that there's a philosophical shift. WESs will become WELs, workplace exposure limits. So these are values not to be exceeded, whereas the WES allows for deviations up and down from that mean value. So we'll also note that you know, if a fabricator is bringing in a hygienist for air monitoring, you know, in the here and now, it would be wise to keep your eye on those 2026 values, because, as I say, they're going to be coming into force fairly soon, and so, you know, whilst you might be currently compliant, be aware that very soon you may well not be. Okay, I mentioned that I would also talk about some of the other hazards, and this is a slide that just sort of highlights a few of those. You've got things like ozone, which Bruce has already spoken about, but other things that have cropped up, people might not be aware of: phosgene, LPG, so that perhaps relates more to the way of generating heat if you're using LPG as the source. Same with acetylene. The process itself might either create excess oxygen or a depletion of oxygen, and each of those has its own particular hazard. So excess oxygen increases the explosion hazard, and oxygen depletion, well, of course, that will be problematic for a worker in that environment. And zinc is another metal that is often evolved. So that's just a few of the additional chemical hazards. There are also a few other ones. Other things that you might need to think about, and I think Bruce again sort of briefly touched on this, but it's things like UV, infrared, electrical shock, electromagnetic fields, the risk of fire and explosion, simply the thermal harm from being near a very hot process, noise too, because it can be a noisy process, often working in confined spaces, the risk of falls, all of those things are things that need to be involved in your risk assessment process.
Yeah, thank you, Richard, for all of that. Just before we, oh, no worries. Sorry, I just saw someone in the chat said they couldn't see the slides, but it looks like maybe that's just an issue with that person's computer. Yeah, cool. We're sorting that out. Okay, no worries. Can everyone else see the slides? Can you just give a thumbs up in the chat or something? Yeah. Okay, good. Thank you for that. I appreciate it. All right, we'll continue now. Thanks, Richard. So yeah, it's important to remember, I guess it's not just the chemicals that are hazards when welding, like there's all those other things as well that we need to think about. I think UV radiation is one that kind of, you know, when I thought about it, I thought, yeah, that makes sense, you know, the light coming from the welding. So good things to think about. This next question is for both of you. So what are the risks associated with exposure to weld fumes?
Okay, yeah, Bruce and I are tag teaming on this slide. So yeah, there's current emphasis on the potential carcinogenicity of weld fume, but we mustn't forget that there are quite a number of other serious health consequences that are associated with weld fumes, and that might actually be far more likely to incapacitate welders.
Yeah, that's right, Richard. Firstly, let's look at you've got short-term effects, and the most common one that's well known is metal fume fever, and it arises due to excess exposure to zinc fumes and fumes from other metals that can induce flu-like symptoms in the exposed person. Now, recent research in mice is indicating that metal fume fever may in fact arise in susceptible individuals due to an allergy response to the contaminant in the fume. Now, once the individual is removed from the exposure to fume, symptoms will pass after a few days rest. But please note that contrary to popular belief, consuming a carton of milk accordingly will not prevent nor will it cure metal fume fever.
Yeah, there are also serious long-term health conditions that might affect welders exposed to excess fume. So that can include lung diseases such as COPD, pneumonia, bronchitis, occupational asthma, or respiratory sensitization. Welders are more likely to be afflicted by those than lung cancer.
Yes, and just a heads up, managers and supervisors, for those of you who are online today or will be looking at this, the video of this presentation, that if you find your welders are taking a lot of sickies, especially if they relate to respiratory complaints, it would be very wise to check how efficient your fume controls are. Recently, a Weld Australia staff member visited a workshop where the manager complained about too many welders being off sick at any given time. It was observed that the general ventilation in the shop was poor, with an absence of fume capture, and the fume could be hanging in the air. Now, they also welded through galvanized coatings periodically, which doesn't help. Essentially, the employer was the master of his own destiny, as the work was a major contributor to his welders' poor health.
And there are other adverse health effects linked to weld fume. Manganism, caused by excess exposure to manganese fume, for example, and that produces Parkinson-like symptoms. Now, the jury is still out on whether manganese causes Parkinson's disease, but the symptoms are similar. Yeah, so that's one to look out for if manganese is a component in the weld fume.
Thanks, guys. So Richard, the question that's probably on everyone's minds today, what controls can PCBUs put into place to manage the risk of exposure to weld fumes?
Yeah, I'm glad you asked me that question. First and foremost, don't just reach for the PPE. Yeah, we would like you to think a bit more intelligently and apply the classic hierarchy of controls. So this is a very familiar diagram, the respiratory controls carrot. We expect PCBUs, businesses, to be able to demonstrate that they've gone through that higher level thinking before reaching for the catalogue and ordering the PPE. So for arc welding, opportunities might be a bit limited, and sometimes the only option available might be to actually introduce PPE. But having said that, substitution and engineering control options do exist, and we expect those options to have been considered before moving to PPE. In the event of a visit from your local Safe Work SA inspector, an absence of engineering controls in the workplace will no doubt raise some doubts in their mind, and they're going to be looking for evidence of the verification of controls, some air monitoring by an occupational hygienist.
Yeah, perfect. Thanks, Richard. So Bruce, can you give us some practical examples of the control measures using the hierarchy?
Certainly. Well, the first one is the most obvious one, but it's not always possible. And that is remove the welder from the arc source. And that effectively reduces the risk of exposure to the welder. Now, options here include the use of the submerged arc welding process where feasible, or you can mount the welding torch on a buggo or travel carriage. And I have actually used a flux cord arc welding torch mounted in such a system to complete with a flexible extractor tubing mounted on the tractor. It's not always feasible, but it is very effective. Another option that has become evident in recent years is via the use of cobots. Now, cobots are a small robot designed to work in close proximity to people. Now, they are easily mounted on a mobile workbench and they can be readily moved to the workpiece. I am aware of one cobot being used, for example, inside a dragline tub in a Queensland coal mine. Now, the use of processes that produce reduced rates of fume may also be a viable option. For example, we know that gas metal arc welding or MIG welding with a solid wire will produce about a third of the amount of fume typically generated when a flux cord consumable is used. For welders using non-waveform controlled power sources, that is conventional power sources, fume minimization is possible by ensuring that a qualified weld procedure that maximizes arc stability are followed. Furthermore, the use of an inverter-based power source also enhances process stability. And lastly, the use of copper-free welding wires, that's gas metal arc and flux cord, further reduces weld fume generation. With a gas metal arc process, the process can also be modified to minimize weld fume generation through the use of waveform controls, and I'm talking here about control dip, STT, pulsed welding, etc. Now, application of these controls can reduce the fume generated by up to 80%, so that can be a huge reduction. Further reduction in fume generation is possible by reducing the carbon dioxide content of the shielding gas where that is technically feasible. Now, evidence is now emerging that a similar reduction in fume also occurs with lower carbon dioxide shielding gas used on flux cord wires. For users of the flux cord process, wires are available classified for use with argon with a 10% CO2 shielding gas that minimise weld fume in a manner similar to gas metal arc. Now, in the USA, for example, classification of flux cord wires is very commonly uses a 75-25 argon CO2 mix, whereas in Europe, they've transitioned more to an 80-20 or an 82-18 mix is very common. Now, the 90-10 mix is now emerging due to the need to minimise fume. Now, this next slide clearly shows the benefit of using waveform controls if the power source is fitted with such an option. This option is typically available in better quality, newer inverter-based power sources, particularly for gas metal arc welding, where waveform controls such as those marketed under variants such as CMT, LSC, RMD, or the STT process, or the higher current pulsed welding can reduce generated by up to 80%. The top two photos in this slide are real effects, and they clearly show conventional spray mode welding on the left and pulsed moding welding on the right. It also has been established that the level of carbon dioxide in the shielding gas has a significant impact on the amount of fume emitted. Reducing the carbon dioxide content from 18 to 10% can nearly halve the level of fume generated. Be aware though that reducing the CO2 content of the shielding gas may not be feasible from a technical perspective, as it may adversely affect the weld metal properties and classification of the welding consumable. This said, consumable manufacturers are currently extending the classification range to include the argon 10% CO2 or M20 mixes. Evidence is now emerging that these strategies using alternative shielding gas mixes are also effective in the minimisation of weld fume for the flux cord process, including the use of metal cord wires and the welding of stainless steels. Important, as indicated previously, at all times aim to maximise arc stability to minimise the evolution of welding fume. Now, for fume control, regulatory authorities typically expect fume to be captured at the source when generated. Now, this can be via hooded capture devices or on-gun extraction systems. Efficiency of capture varies, but can be up to 90% effective for most fume constituents. Be aware, though, that it is ineffective against protection from ozone, as ozone is typically generated away from the arc due to the action of ultraviolet radiation on atmospheric oxygen. Fume capture is essential, not just to protect the welder, but to protect those working nearby. And similarly, good general workshop ventilation is also a must to protect those also working nearby. Importantly, if fume generation can be minimized, there will be less fume to capture, and therefore the engineering controls will be much more effective. If the welder's head is in the plume, it is known that fume capture alone will be insufficient to protect the welder given the 1 milligram per cubic metre time-weighted average limit, and additional fume controls will be required. As previously stated, if there is a lack of engineering controls in use, it is likely that a regulator will require a formal fume assessment to be performed. However, real-time fume monitors are now available to assist fabricators to demonstrate compliance for those in working nearby welding operations. Now, as previously indicated, if the welder's head is in the plume, it is known that fume capture alone will be insufficient to protect the welder given the 1 milligram limit. Other issues for consideration include, but are not limited, limited joint access, weld position, and emission of hazardous particulates with low exposure limits. Whilst fume capture is essential, personal respiratory protection is also recommended, and powered air purifying respirators are known to be especially effective. A well-maintained PAPR unit provides good positive pressure of filtered air in the welder's breathing zone, where in excess of 99.5% of weld fume can be removed or prevented from coming into the breathing zone. Now, because ozone is generated remote from the arc due to the action of the ultraviolet radiation on the atmosphere, local capture devices are at best only 50% effective at capturing ozone, and additional control is required to minimize the welder's exposure levels. PAPRs can be highly effective at eliminating the welder's exposure to ozone, primarily because they draw air from behind the welder, where there is usually a low incidence or absence of ultraviolet, and therefore ozone behind the welder. If necessary, an A1 filter can also be added to the PAPR's filter pack to remove ozone should it be required. But that's not the end of the PPE story. Now, why can't PCBUs just use a PAPR? Well, as you may realise, a welder wearing a PAPR is the only person protected during welding, and they are only protected whilst the face shield is lowered. Once it is raised, the welder, just like anyone else working nearby, will be exposed to the weld fume unless engineering controls and good ventilation is in place. Therefore, a combination of controls is usually essential. As previously stated, if there's a lack of engineering controls in use, it is likely that a regulator will require a formal air monitoring assessment to be performed. Portable real-time fume monitors, which I will show shortly, are now available to assist fabricators to demonstrate compliance for those working nearby welding operations.
Thank you for that, Bruce. That was really, really in-depth and some really good ideas there of how businesses can manage the risk. So Bruce mentioned air monitoring and air assessment. So Richard, from the regulator's perspective, is there a requirement for PCBUs to conduct air monitoring?
Well, yes. Compliance with the WESs will require measurements to be conducted in the breathing zone, and so there are some guidance documents here. There's Safe Work Australia's guidance document there. Yeah, and it's quite clear that in order to demonstrate compliance with a WES, you're talking about measurement within the worker's breathing zone. And as Bruce was demonstrating earlier, particle size does matter because it affects the way that the substance impacts on the respiratory system, and therefore it might affect the particular target tissue or disease outcome. But I would say that in practice, determining particle size can be quite a difficult thing to do. And well, maybe in some senses becomes a bit of an academic argument in terms of compliance with the numerical value of the WES. But as I say, it does matter because it affects distribution and it affects disease outcome. So yeah, here's a very simple schematic that shows the you've got a sampler there that's in the breathing zone. Now, again, just referring back to Safe Work Australia's guidance document, to be clear, the breathing zone is a 30 centimetre diameter, essentially around the head. So it can be measured behind the head, and that might well be important in terms of practicability in determining personal monitoring values. In addition to compliance with an airborne standard, there might be some requirements for health monitoring. So Regulation 368 speaks, well, it cross-refers to a list of chemicals in what's known as Schedule 14, and that list includes things like lead and cadmium and chromium. But also, well, Schedule 14 is identifying what needs to be done as a minimum, but also within Reg 368, there is scope for conducting health monitoring essentially on any hazardous substance, providing that there is a valid measurement technique. And the clause that's currently there is if there is a significant risk to health. And well, significant risk.
Yes, yes. What do the regs mean by significant risk?
It's a bit of a vague term, as you can tell.
Yes.
And all I can say is that Safe Work Australia is currently producing some discussion papers on this topic and thrashing this out amongst the states and territories, which sort of leads me to this as a starting point. What's been pieced together here? This has been plucked from the current regulations related to respirable crystalline silica, and there's a bit there that refers to well, typically half of the workplace exposure standard. That's sort of used by occupational hygienists as an action level. That's often an indicator that a work site's control measure systems might have gone awry. So significant risk, I'm throwing it out there, you know, in terms of consistency with silica regs, well, maybe half of the WES is what is a trigger for significant risk. And Bruce is going to talk about some of the other tools that might be useful for checking significant risk.
Thanks for that, Richard. Yes, I've got on the screen here 2 examples of real-time monitors that are now available on the market. Now, whilst these units continuously monitor air quality, some of them use a traffic light system to report air quality, and data can actually be downloaded from these units by mobile phones. It is recommended that these units be set up to trigger a warning or a yellow light if 50% of the exposure limit is reached, and a red light if the exposure limit is reached as well. Now, the two examples that are shown on this slide, on the left, we've got the Plim Event unit, which is sold by Apex Welding Safety. I think it's called the Errorguard. And the Kemper unit on the right is sold by a company called Smenco. And there are other known units on the market as well. An instrument is also has become available that is marketed as a scientific unit. Its cost, though, is of an order of magnitude higher than the real cost monitors or the real-time monitors. Importantly, though, with these units, please be aware that they are a useful tool to provide workplace guidance on a general dust and fume levels, but they are not a substitute for air monitoring performed by a hygienist.
Cool. Thanks for that, Richard and Bruce. So, Bruce, if PCBUs, if they want some more information about managing exposure, some more detail, where can they go?
Well, they can go to Weld Australia's fume minimisation guidelines, and they can be downloaded free of charge via the resources tab on the Weld Australia website. And this guideline contains an audit prompt sheet for weld fume in the appendix. Further guidance is also available from Weld Australia's Technical Note 7, Health and Safety in Welding. And on your slide, you can see 3 barcodes there, or QR codes there, that will take you directly to a number of resources available. Weld Australia has set up a specific web page on the fumes that we put that one up very quickly after the surprise announcement back in January last year about the sudden change. So,
yeah, and there's a few SafeWork SA, or there's the SafeWork SA webpage, and also the Code of Practice as well from SafeWork Australia. So yeah, different resources there.
Now, just what we're now about to move into a Q&A session with Richard and myself. Now, whilst you are preparing your questions, if you haven't done so already, I would like to briefly draw your attention to some upcoming Weld Australia events, which you can see on the screen. Now, we have a free online presentation on the 20th of March, which is next week, to assist the fabrication industry, especially those performing hot works, and that is navigating insurance pitfalls in metal fabrication. A number of fabricators and contractors have had their insurance voided due to non-compliance with the Australian Standard 1674 Part 1. And for those of you online who are involved in the fabrication industry, 1674 Part 1, the 2025 edition was released on the 24th of January just past. And 1674 Part 2 was currently being revised, and it's out for a committee ballot as we speak. Now, we've got some other alternative upcoming training courses, as you will note, and some events nights in a range of states that will permit you to socialise with your clients and industry contacts. Now, Katie, if everybody is ready, we can commence our Q&A session.
Perfect. Thanks, Bruce. So, so we will start the Q&A section. So there is already quite a few questions, but if there's any others, please get in there. We'll answer as many as we can. So first question, and I think this is more directed to Bruce. Can these units actually be related to the workplace exposure limit as it is based on an 8-hour time-weighted average? As I understand, these just give you a number based on the measured fume level at a particular point in time. How do you relate an instant in time with a time-weighted average?
That one I can't answer, but it's there as a guide to show whether or not you've got a general fume problem in the overall atmosphere. And it's primarily there. I think they were initially set up as dust exposures, but this technology emanates from Germany actually, And I recall some presentation about 5 years ago where the German researchers were using lasers on welding fume to look at these, whether or not they could get an instantaneous reading of the fume levels. As far as I'm aware, it's a measure of the fume evolved at that given time. But if it is down at the very low or green level, if set up correctly, the exposures of people in the area are known to be very, very low. However, they are not a scientific instrument, and if you need, but whilst they're a useful tool, you may, if you haven't got a good capture and fume controls in place, as we've said on a number of occasions in this presentation, you will almost certainly be tapped on the shoulder by your friendly workplace inspector and reminder that you will probably need to get a formal assessment done, and then you can relate the two numbers together if you need to.
I think that might pitch into the next question. How frequently do we need to engage hygienists?
Yeah.
This is a bit of a how long is a piece of string question, and it's really quite variable depending upon the complexity of your business, because it isn't defined anywhere. Oh gosh, where do I begin? Sometimes the world of gathering air monitoring data, it's possible to cherry pick information that's been generated from a different work site with a similar set of conditions, as long as you can make a reasoned argument to the regulator as to why it applies to you in this instance. So that's one thing. Typically, I mean, the world of occupational hygiene likes to perhaps perform annual or 2 yearly measures, but again, this sort of depends on the complexity of your workforce. It could be that 1 year you're looking at a particular set of half a dozen individuals, and then the following year you're looking at a different set of people. So much depends on how big and what resources you've got available to you. There is a company I was visiting just yesterday, in fact, and they were talking about doing hygiene measurements on a 6-monthly basis to try to get their sort of baseline sorted. And actually, just the day before that, a different site I was at. Now, this is not related to welding. This is just in general terms about measuring airborne exposures. But this site, it was an enclosed work area, and it had 25 static monitors scattered around the site. Now, bearing in mind the discussion that we've had about static monitors, I mean, they're quite a good way of just tracking whether you've got a problem or not. Well, they had 25 dotted around the site, and they were recording once every month. Now, that's in addition to the periodic annual or twice or once every 2 years determination of personal monitoring value. So much depends on the size and complexity of your business and whether you can read across from other similar industries or not. So yeah, that's the sort of how long is a piece of string question.
Cool, thanks, Richard. So next question here. So is it acceptable to skip the monitoring and apply controls? And in this particular case, this person says a small regional organisation that only welds on an irregular basis, mainly for maintenance.
Yeah, now actually, again, just yesterday, an inspector came to me with a very, very similar query. Now, the scenario, so the inspector had gone to a site that's doing quite a lot of welding. I think there's about 30 people employed at this site. Now, and there was a hygiene survey conducted by a third party, and it identified a couple of things. That there were exceedances of the workplace exposure standards, the current ones, for total welding fume and for actually for some of the individual components as well. But the hygiene report also noted that nobody on this site was wearing any form of respiratory protection. So straight away, I'm afraid my advice is that's a prohibition notice. that thou shalt not do that at all. Now, so a prohibition notice to be applied, but also I think the inspector now he's expecting that the PCBU will reach for the catalogue and order some Airstream hoods as a way of, haha, we're complying with your prohibition notice. That might be true. However, as Bruce and I have already indicated, we would awfully like you to do that higher level of thinking. So in this case, at the same time as issuing the prohibition notice, I think there's a sense of writing an improvement notice to review the working systems and apply the higher levels of control, like on-tool extraction or LEV, because, well, effectively you're going to be reducing the demand on the Papa hood system. And as Bruce said, in some situations, the way that people work, you flip up their hood and they're exposed. So we do expect you to have higher level of control as well. So is it acceptable to skip the monitoring and apply controls? Well, if that's a yes and no. Yes, it quickly complies with, in this case, a prohibition notice, but there's definitely an expectation of you should be doing more to control exposure at point source.
Yeah, thank you, Richard. We've got another question here, and we're getting quite a few now, so we'll try and get through, like I said, as many as we can. If we don't get to your question today, I'll show you in a minute. We've got some contact details for both Safe Work and Weld Australia, where you can direct questions to. So there is often reluctance to control welding fumes at the source by using on-tool extraction and local exhaust ventilation because it affects the weld quality. Can you comment on extraction affecting weld quality? Is it a myth?
It is and it isn't. Some of the early on-torch units didn't handle the extraction system very well, and they tended to draw the shielding gas away from the arc where it was required, so you'd get some porosity in your weld. However, all the modern torches, and I think even the older torches, like a common vacuum cleaner, they actually have a little device on the handle there for the welder to adjust, where they can open that handle, open that contact, and it hides a little hole underneath, so it can actually slow down the extraction rate if necessary, if the welder thinks they're drawing away too much shielding gas. The other point to note too is it's important to make sure that you don't have too much shielding gas flowing through in any event, and that's why a fairly typical recommendation is 15 to 20 litres per minute shielding gas, whereas a lot of welders will often turn that up much higher. And the problem with a much higher level of shielding gas flowing is, yes, to some degree it protects the arc, but it also creates a whole lot of turbulence, and that in itself is a problem. Now, in terms of the hooded capture devices, they need to be located quite appropriately to work properly. If they're too far away, their effectiveness drops off dramatically. So they're typically designed to be about 1 hood diameter from the arc. So that's probably around the 300, about the 300 millimeter mark usually. If you move that out to about say 500 millimeters away from the arc to give a more general sort of capture, the capture efficiency drops to 50% or less. So you're not going to pick up a lot. Now, the other point to note too is that with these on-gun capture systems, they are very good at what they do, but they are not effective in all situations. They work very, very well when welding downhand in the flat position or the HV position. But once you start getting out of position, you've got convection forces from the heat of welding that tends to draw the fume away from the nozzle, and they're not as effective. So in the overhead position, or if you're working vertical down, the efficiency is going to drop off reasonably quickly. With vertical up, you're moving to some degree with the fume, but again, it's not as effective. I think that's probably the best way I could put it, but the modern torches are usually pretty good. And that little hole I was talking about is down on the handpiece that can be controlled by the welder.
Perfect. Thanks, Bruce. And I think this next one might be sort of linked to what you were talking about just now. Capture hoods, LEVs, on-gun extraction units, etc. These controls are fine for workshop welding or welding using semi-auto processes. In regards to site welding controls, where most welding activities use primarily MMAW process, the control is PAPR and also relying on dilution. Is there any other practical controls that could be implemented, or is PAPR and dilution adequate?
Well, you've pretty well, natural air movement can be problematic if you're outdoors because you're reliant on the wind. Sometimes a bit of, if you can set up the system so you've got maybe a bit of a fan on the side to blow the fume away from the welder, that can help, but you don't want to set it up so that it creates a gale because you'll lose the protection. But PAPR and or some type of hooded device is pretty well the only way you're going to protect a welder using a manual process like that. Now that's with the stick welding process.
Thank you.
Can I cherry pick another one, Katie?
Yeah.
So I've just seen in the margins there. There was a question related to the WES for hexavalent chromium to be reduced so far as is reasonably practicable, and the question of what is so far as is reasonably practical. Again, another suitably vague regulator's term. I suppose in the context here, so if you've got exposures that might include exposure to hexavalent chromium, again, going back to the message that Bruce and I have been repeating, don't just have respiratory protection. We are, in terms of the so far as is what is reasonably practical, right, well, we expect some additional engineering controls. And again, that then becomes a bit of a discussion between the PCBU and the regulator at that point as to exactly what is economically viable or whatever, but certainly more than just RPE, respiratory protection.
Just to add to that, Richard, I should also add that the people who are likely to be exposed to Chrome-6, other than people working in the plating industry, for example, if you are welding stainless steels, your welding wires are going to contain high levels of chrome, and also if you're doing hard facing, for example, a lot of those wires and consumables have a lot of chrome in them as well. So that's where you are likely to potentially generate Chrome-6 in that. For conventional welding using standard mild steel type welding consumables, your welders are not going to be exposed to chrome 6. There may be some small additions of chrome in some low alloy consumables used in pressure equipment, for example, but they are usually at a very low level, and you're certainly not going to detect chrome 6 in those circumstances. But there is a chance, if you're dealing with welding stainless steels, that's when you are going to produce, or you are possibly likely to generate it. Now, how to eliminate it, that's something we just don't know at the moment. And it's a question I have asked Safe Work Australia in relation to what they're planning to do in December 2026. How are we going to comply with that? Because that's the question people will ask people like myself and others within Weld Australia and other similar organisations.
Thanks, Bruce.
Oh, thanks, guys. So just one here for Bruce. Is there a template available for the formal welding fume assessment / formal air monitoring assessment mentioned by Bruce when discussing the hierarchy of controls?
I'm not sure what the inquirer means there. If you go to our fume guidelines, we have included a checklist there on on how to manage weld fume. That's something that's in the back of that particular document. That would be the closest thing I think that would be available to a checklist. Now, going back many years ago, before we produced those fume minimisation guidelines, Standards Australia did attempt to produce a standard on management of weld fume. However, there were certain industries that where this proposal went down like a lead balloon, and they arced up, and there was it was actually quite a campaign back in the 1990s to kill it. Unfortunately, they succeeded, but out of that, the research project that ultimately produced the fume minimisation guidelines arose. Now, if there is a need for some sort of fume checklist document or anything like that, would be useful to the industry. I'm currently revising our WTIA Technical Note 7 or Weld Australia Technical Note 7 on welding health and safety. So if there's a need for documents like that, we can certainly look at putting something in that particular document.
Perfect, thank you. I think we might do two more, just because I'm conscious of the time. And if we don't, as I said, if we don't get to your questions, please contact us after, and we're more than happy to answer them. So welding in some confined areas restricts the use of on-gun fume extraction, the use of PAPR, and even the installation of mechanical ventilation and extraction. What are your thoughts?
Confined spaces are a whole problem in a nutshell. And to that degree, there are regulations on what's required for confined spaces, but that's not the end of the story. As we speak, Standards Australia are looking at the option of revising the AS 2865 to help with that particular situation. So the project hasn't been submitted yet. I know that because I'm the one that's going to have to write the submission, but it hasn't gone in at this stage because we're still in discussion in committee about what needs to be done. And once we've got that sorted out, we can then present the requirements to Standards Australia, and then we can get on with doing the revision. So that's a work in progress, that one.
Yeah, perfect. Thanks, Bruce. All right, and this will be our last question for today. I think we've basically got through pretty much all of them. Yeah. So does hexavalent chromium dilute into the surrounding atmosphere? If fume extraction is 90% efficient or less, will other personnel in the area require PAPR? Our air quality sampling in the breathing zone of the welder almost always shows an exceedance of the limits. At what distance do we need to monitor CR, what's that, 9?
That's chrome 6.
Chrome 6, yep, levels for passive exposure.
That's a Richard question, that one.
Is it?
I was opening it up to both of you. So
Yeah, I'm just trying to see if scroll down to the question again. Well, clearly there's, yeah, as Bruce said, there are some circumstances where the air monitoring of the worker alone is not necessarily demonstrating compliance with airborne exposure standards. I mean, fine, you're protecting the safety of that worker, but as Bruce said, you've got to be mindful of who else is in the work environment there in, often nearby, and perhaps the best way of determining that is by static monitoring. So you'd really just have, it's a case of positioning static monitors, I don't know, 2 meters away, 3 meters away, and scoping your particular work setting in that way.
You'd have to have a particularly specialised monitor to pick up Chrome 6, I'd expect, though, Richard, wouldn't you?
Yeah.
Yeah, those units that I showed will only detect general fume, and they certainly detect down into the submicron region, which covers welding fume, but they're not aligned with any particular component of fume.
Perfect. Thanks, guys. So we're going to wrap it up now. So if any of you had any questions in there that you didn't get in time or we didn't have time to get to, please feel free to contact us, so contact SafeWork or Weld Australia, and those contact details are on the screen there. That 1300 number is just a number to our help centre where we can then pass on the message to Richard and our experts. But the Weld Australia number is their fume hotline, so that will go direct to Bruce, to you, I believe, and
yes, and it'll also, and if I can't pick up the call, it'll then divert to one of my colleagues, and if he doesn't pick up or can't pick up the call either, which does happen from time to time, you will go through to a message bank, and then we will get an email with your details.
Yeah, perfect. Yeah, so definitely utilize that, or send an email through those channels if you have any additional questions. So thank you for joining us today. We hope that you found that information useful and that you can take something away from today. Just a big thank you to our presenters, so Richard Carey-Clark from SafeWork and Bruce Cannon from Weld Australia. We really appreciate your time today and your input. And as I said, that's all from us here. So if you have any further questions, use those channels there on the screen. And thank you very much. And we hope to see you again in another SafeWork SA webinar. Again, this recording will be uploaded to our YouTube channel in the next few days. And I had a question there about will it be sent out? So we're planning on sending a link out to all the people that were signed up as well. So you should get that one soon.
And I would imagine we do have a welding page within SafeWork SA's website. So we'll be creating a link within there that makes reference to this presentation.
Yeah, that will be in there too. Brilliant. Thank you very much, everybody.
Okay, thanks, Katie. Thanks, Bruce.
Thank you, one and all. Thank you, Richard. Thanks, Katie.